Hello, welcome to Building Systems with Functions. Here's what this section of videos covers. This video will show how to use pure functions to improve the expressiveness and safety of your code. In the second, we'll see how higher order functions make it easy to implement the dependency injection pattern, and we'll use that to separate pure and impure function behavior. The third video shows how you can reuse functions more easily by creating partial functions. In the next, we'll see how function composition lets us build complex behavior by chaining together smaller functions. In the final video, we'll see how to build the state machine pattern using functions to control how data changes in our applications. The functional programming techniques you learn in these videos will open the way to building large-scale, real-world systems. So, welcome to Pure and Impure Functions. In this video, we will learn the difference between pure and impure functions, and we'll see how pure functions make code more expressive and safe, and how they make it easier to combine functions to build systems. We'll identify some of the common things that make functions impure, and we'll discuss some ways to separate pure from impure functions. If your background is in object-oriented programming, you may never have heard of the term pure function. A pure function is simply one with no side effects. That is, it takes 0 or more arguments, returns a value, but has no other effects on the system. That isn't quite literally true, of course, since all functions do use computer resources like threads and memory, but those are not considered side effects because they have no effects that your program can detect. An obvious benefit of pure functions is that they are easy to understand. You can tell from the function signature what arguments it takes and what it returns. You may want to look at the function body to understand how it returns what it does, but you know it doesn't depend on any input besides its arguments, and it doesn't do anything besides returning its value. Another important property of pure functions is that they are idempotent. This means that whenever you call a pure function with a given set of arguments, you'll get the same result back every time. Because of these properties, pure functions are easier to test. You could be confident that if the function returns what you expect given the arguments, then it's working, and you don't have to worry if it's doing things you didn't intend. Because it has no side effects, a pure function can be combined with other pure functions, and the resulting system will also have no side effects, making it easier to understand and control. We'll be looking at ways to do this throughout the remaining videos. What can make a function impure? Basically, doing any kind of input or output within the function body. For instance, reading the current date and time from the system console makes a function impure. The next time the function runs, the date and time will be different. Likewise, writing messages to the system console may seem innocuous, but it makes the function impure. And then we come to the really obvious things, like inputting data from files, databases, or external services, and writing data to files, databases, or external services. These can hardly ever be done except in an impure function. Of course, real programs usually do need to do input and output, so you can't make everything pure. But what you can do is design your function so that the impure behavior is separated from the pure behavior. If you need to get the system date and time, for instance, you can write an impure function that retrieves the date and time, and then use one of the techniques we'll see in the coming videos to use that impure function with your pure functions. Some programming languages force every function to be pure unless you take steps to allow impurity. Haskell is a well-known example of such a language. But F# does not force functions to be pure, and it can't detect whether a function is pure or impure for you. So separating pure from impure functions is your responsibility. In the next videos, you'll see some techniques to help you do it.